Okay, so this is the 1992 problem. And in this, we have a barbell apparatus with two identical spheres of mass m on either side, and we have a bug of mass 3m which just landed on this side. So in part A, it's asking us to find the total torque acting on the system right after this bug lands. So in order to do that, you have to take into account all the forces acting on the system, and you have to multiply each one by its radius r from your fulcrum. So in this problem, we chose our fulcrum to be in the center of the axis. So we have, on this side, a force of 4 mg acting and a force of 1 mg acting on that side. Now, since we chose our sign convention to be positive in the counterclockwise direction, when we're writing out our torque statement, then the torque exerted by this weight would be positive, and the torque exerted by the weight of this mass would be negative. So you end up getting that the total torque is 4 mgl minus mgl, and you end up with a total torque of 3 mgl. Alright, for part B, it asks you to find the angular acceleration. So we know that torque equals moment of inertia times angular acceleration. So what we're first going to do is find our moment of inertia. So we know that's equal to m times r squared of each section of it. So in here, since we only have two significant spots of mass, then our moment of inertia would end up equaling 4ml squared plus ml squared. And then you end up getting that your moment of inertia is 5ml squared. So now, in part A, we found that the total torque is 3 mgl. And we just calculated that our moment of inertia is 5 ml squared. So we plug both of them in, and we end up calculating that our angular acceleration is 3g over 5l. Alright, for part C, it asks you to find the angular speed of the bug. So in order to solve this, what we're going to do is use energy. So initially, when you have your rod horizontal like this, you have a potential energy of 5 mgl. You have no kinetic energy in translational or in rotational. And once the bug is on the bottom right here, and you have the barbell vertical, then you have a potential energy of 2 mgl, which comes from this top part times your 2l. And then you also have a rotational kinetic energy, which came from when the bug caused the barbell to rotate this way. And that would equal your 1/2 I omega squared. So you know that energy is conserved, so you know that your final energy minus your initial energy equals 0. And that means that you know that your final energy equals your initial energy. So you plug in all your values here. So your final energy is just 2 mgl plus 1/2 moment of inertia times omega squared, and that equals your 5 mgl. Okay, you solve through it, and you end up getting that your omega is equal to the square root of 6g over 5l. Okay, so now the next part asks you to find the angular momentum of the system. So we know that the equation for angular momentum is just I times omega. So we just plug in our values that we found, since we found our omega back here, and we found our I over here. So we just plug that in, and if you simplify and everything, you should end up getting the square root of 30g m squared times L cubed. Alright, part E asks you to find the magnitude and the direction of the force that must be exerted on the bug by the sphere to keep the bug from being thrown off the sphere. Okay, so you know that your force keeping your bug on the sphere at this point is partly due to your centripetal force, and we learned earlier that our centripetal force equation is v squared m over r. So, using our omega equation, since we know that omega r is equal to our v, we would multiply that all through, and then you plug in your m value and your r value, and you end up getting 18 over 5 mg is equal to your centripetal force. However, you know that the force of the bug acting on the thing is actually, the force of the bug minus its weight is equal to your centripetal force. So, and since you're solving for the force of the bug, then you have to also remember to add on the mass, the weight of your bug. So you end up getting 18 over 5 mg plus 3 mg. And so, yeah, that's how you that's how you solve. Oh, and the direction, the direction of the force acting on all of this. Since the bug is hanging downward on the apparatus, then the force direction would have to be straight upward. Okay, so that's how you have to solve the problem 1992.
Oh, and the answer was 6.6 mg. Okay,
I
yeah,
don't
but
think that's necessary. It's the same thing.
still recording.